So if you ever want to say anything about predicting an earthquake, there are really three things that you want to know. You want to know where it's going to be,
Right.
how large it's going to be, and when it's going to be.
Right.
And so I've devoted much of my career to trying to answer those questions. In truth, we're not great at it yet. But we're approaching it in some new ways with some new technologies that are allowing us to see things that we never could before, and honestly make predictions that we never could before. So the first tool that was the real revolution for us was the ability to not study earthquakes like seismologists do. Seismologists largely study the aftermath of earthquakes. They study the little seismograms.
So they instrument the ground and see what it's doing during an earthquake.
Yeah.
Right.
That's less than 1% of the time of what the Earth's doing. The rest of the time, the Earth is preparing to have its next earthquake. So what we want to do is we want to study that. And that's invisible to seismometers. But it is very visible to GPS. So when you take out your phone and you want to go somewhere, what's the first thing you see? You see a blue dot, and that tells you where you are. How does it know where you are? It's listening to GPS satellites that are 20,000 kilometers above the Earth's surface. So GPS tells you position. Turns out you can do kind of an industrial version of GPS, not with kind of a phone, but with a big antenna about this big. And with those, we can measure the Earth's surface movements with the precision of 1/10 of a millimeter per year.
So that's like if I took my fingers and almost pushed them completely together. That's
Yeah.
1/10 of a millimeter.
Yep. Yeah, it's
Yeah,
thinner
that's
than
way
your
more.
fingernail.
Yeah.
And so we can measure that all across the globe now. And the reason that that's important is because that's far below the velocity that tectonic plates move.
Okay.
And so one of the things we can do is we can not only see the motion of tectonic plates, but more interestingly, we can see where they come together and grind. This is going to be the place where a future large earthquake is. We can actually measure the buildup of elastic strain energy in the Earth's crust. And then we can take...
Is this 3D measurement or 2D measurements? Like this is...
Yeah, we take them in full 3D measurements on the surface of the Earth.
Okay.
Sadly, they're only surface measurements. And what we want to do is we want to convert those measurements into a model of what a future earthquake will actually look like. And so we spend a lot of time building these computational models that take these surface measurements and then turn them into estimates of where a fault will rupture and how big an earthquake there might be.
Reading about the John Snow Club.
Learn more at predictionx.org, where you can stay up to date on all of our latest offerings and interviews.